Hey, you've made it to video 3. We are over halfway done with this section, so let's get going. 0.3.3, we're talking about compound interest. One big idea here, it's going to be the compound interest formula. No new vocabulary terms in this particular section. So let's go ahead and get moving. We're going to talk first about the compound interest formula. We bring this up again. Now, I know we talked about it in the first video here with $100 being invested in an account that earned 5.5% interest, but I want to dive a little bit deeper because interest is not just compounded yearly. You can find that different accounts, different banks, different types of investment are going to compound their interest over different periods of time. Some are annual, some do every year, some might do it quarterly, where you get an interest amount every 3 months. Some might be monthly, where you get an interest compounded literally at the end of every month. A lot of savings accounts are that way. So we want to dive a little bit deeper into that formula. Here's what it looks like. If an account begins with some principal P and earns an annual interest rate R compounded in times per year, then the value of the account in T years is this formula. P times the quantity, 1 plus R over N to the power of NT. So let's mark this up just a little bit. P, that's the principal, right? That is your initial investment. So in video 1, our principal was $100. 1, make sure that you still have your principal after you do your compound. R is the rate. That's your interest rate in decimal form. N is the time period of your compound. So how many compounds do you get per year? So I'm going to put here number of compounds. And then this is going to be raised to the power of NT. So that's the number of compounds per year, and T is years, of course. All right, so let's clear that out. Let's go back to our mouse and go over to the next slide. Here's an example. Christina deposits $2,500 in an account earning 5.4% annual interest rate. Find the value of the account in 10 years if the interest is compounded, and then we're going to do it 3 times, annually, quarterly, and monthly. Let's start with annually. What is that going to look like? Well, here's the formula. It's your P principal. Oh, we went a little too far there. It's your P principal times 1 plus. Here's your interest rate, 0.054. See, now here's where we kind of skipped over the division portion of the rate over N. It's the number of times you compound per year. So since we're compounding annually, there's only 1 compound per year. We really didn't need to go in there and say divided by 1, but we can kind of mark that in there if we want to. And then that's to raise to the power of NT. So that would be 10 years. N, again, is 1. So we really don't need to show 1 times 10. So this turns out to be approximately $4,230.06. We'll put a $sign there. All right, compounded annually, that's what we're looking at. Now, what if same annual interest rate, but Christina found an account that compounded that 5.4% interest quarterly? So that's going to change the formula a little bit, isn't it? So here's that one. 2,500, still the principal, times 1 plus 0.054, now divided by 4. If it's quarterly, it's going to happen 4 times a year, to the power of 4 times 10. That's the number of compounds per year over 10 years. So that product there's 40. And what that's telling us then is that we are going to have 40 separate compounds over the life of this investment. So what does that turn out to be? Well, I think you're going to like the news, Christina. This comes out to be $4,274.55. So what happened? We increased the number of compounds per year, and hey, that increased the number of dollars that we have at the end of the investment. Good stuff. Well, if some is good, isn't more better? What happens if we compound monthly? let's take a look at that. So if we compounded monthly, that formula is now still the base 2,500 times 1 plus 0.054 over 12. 12 compounds. Okay, so what does that do for us? Well, that means for one thing, we're going to have 120 interest compounds during the life of that loan, or not loan, but investment. I think that's going to be a good thing. This is going to come out to be $4,284.82. So the difference between one compound every 10 years or 12 compounds a year for 10 years turned out to be, in this case, on an initial investment of $2,500, about $54. So the more compounds in a year, the better. And that is the key takeaway here for compound interest. All right, I'll see you in video 4.